Have you all set up MFA?
Yes, Samir.
Yes or no?
Yes, that was yes.
Yeah. Yeah, I think this was the first thing I showed you. So with this MFA setup, at least your login is not compromised. So just log in, drop the access keys IDs that you've created and regenerate a new one. You're protected. You have nothing to worry about. Okay.
Okay.
All right. Yeah, I was surprised. I never talked about security because security is always top of my list. So anything you do, you should keep security in mind first. The surface of attack. I think I've talked about the surface of attack. I remember doing something like this. I'll tell you.
You also talked about TF words, Samir, not to commit it, and you made it part of a git ignore. And then
yeah,
you also said, go ahead and change it if it is like I was doing a screen share, I think, because if something was not working for me.
Exactly. I remember that. And I remember also drawing a circle like this and talking about the surface of attack. If you do
Yes,
something
Samir,
like
you
this,
did.
Yes.
there's a big surface of attack, right? So I talked about security groups, how you don't create a single security group for everything. Again, Jyoti, what happened is for a good cause, right? Because then we are able to relate why I was talking about all this. So nothing bad in it. Until the time you do not lose your money, you're okay. But always be careful with credentials anywhere, any credentials, be it JFrog credential, the API tokens that you create, make sure you don't write it on paper slips and keep it around. You should potentially have a vault, which we didn't cover in our sessions. But this is an important topic. My next certification is on HashiCorp's vault. That's my next certification. I've been delaying it for a long time because of the focus that I was not able to put in. But Vault is a very, very important solution. We haven't talked about it, but we have a bigger topic to cover today. So let's keep all of this out. Okay. Let's come to the real topic. Any other question anybody has? Jyoti, I hope I answered the question, what you had.
Samir, thank you. I understand.
Sure.
Yeah.
So now let's get to rock and roll because we have a lot of catch up to do. So what I want you to do is I have sent you this links over here. Just open up. You can open up first one if you want to, but I want you to open this up eventually. And what I want you to do is before you come here, there's a link over here called virtualbox. So click on that virtualbox. And you can start doing it along with me because it will take some time to download, right? And then click on this VirtualBox. It should take you to the Oracle's VirtualBox. And we want a Windows host. Everybody's running Windows, right? Nobody runs Linux or Mac here. So if you run Windows, just click on that Windows host. It should download this VirtualBox for you, okay? Once that's done, I don't think we have anything else to look over here except when we are starting, we have to give the driver as VirtualBox that we have to remember. Okay, so I'll come over here. Now it is coming to minikube start. Over here for installation, select your Windows 64, stable, and exe download. Okay, and then come down over here, download the latest release. You can click here or you can even run this command. So I would click here. It will download the minikube exe for me. I will go again and I'll go to that first link, not the second link, the first link. Okay, click over here. There's kubectl. I'm going to talk about each one of them, but I want you to download and keep them ready and then install kubectl for Windows. And then scroll down, install kubectl binary with curl or Windows, and we'll do it with Chocolatey, okay, because we have Chocolatey installed. Does everybody have Chocolatey installed?
Yes, Samir.
Okay, good.
Yes,
and you'll now know why I had asked you to download it. So this is the command that you'll run. Choco install kubernetes-cli. Okay, let's go ahead and before we do that, I want you to install VirtualBox, then install minikube, and then we will install kubectl. Okay, so I will make notes of it so that I can put it up in the description later.
This VirtualBox is same as Oracle VirtualBox Manager?
It is Oracle VirtualBox only.
Okay, so I don't have to download that.
Yeah. Come on. Close all but this. Right. So I'll put this up in the description of the video later, but I have, except for kubectl, I've downloaded everything. So let me go ahead and install this. I can just right click, open in folder, and double click on this. All right, next, yes, install. Yeah, you can prefer to do it afterwards when you watch the videos, but just follow along what I'm doing. I thought a bit about it. So I got up around 4:30 in the morning today because I had to revise what I'm going to deliver to you. It's a complex topic compared to all the other topics that we've covered earlier. So I wanted to simplify it as much as possible. The initial thought process was I'm going to set it up in AWS. But as soon as you set it up in AWS, you're talking about at least 2 to 3 nodes, right? So it will cost you some money. So we will come there. We want to do everything in AWS eventually, but just to start with, I thought probably we can start here and then go to AWS. Install. I don't know if my hypervisor is enabled or not, but let's check. I will probably pause the video for some time until this goes through. So let's say finish over here. And that's your virtual box. Okay, there's a lot more you can do. You can create your VMs that we were doing in AWS over here. I didn't want to teach you here and then also teach you in AWS because I wanted to start with Terraform outright. So that's how we started with Terraform. So we got to experience AWS and Terraform both as part of the training. But when it comes to Kubernetes, we'll start with minikube just for a couple of sessions, maybe 1 session and 2 sessions like today and tomorrow, and then we'll go to EKS. All right, so this is done. The next one is minikube. I've already downloaded it. I'm just going to double click on it. And I'm going to bring this. You can either run it this way or you can set it as a default. We are going to use default. So I'm going to take this command, put it up for you over here. After it is installed, we'll have to run that command. So open up your git bash. Okay. Sorry. Yeah, so minikube is installed. You can even do this to get all the help, what you need. Good. And now we will go ahead and run this command. I don't think so. We need to do it, but I will just do it anyway. It does not exist. So that's good. We've not even started once. Now, if I go here, see users, I would think there should be something called minikube. So the whole concept, right? .git, .aws, .m2, it's all in your user profile. So you can go here, and this is where it keeps all the cache and stuff, certificates. And then if you look at config, that's the config basically. If I open it up, the command that we just ran, driver virtualbox, that is where it shows up. Okay, so if you do not want it or want to delete it, you can delete it using the command, or you can unset it, or you can come and delete it from here. It's both the same. All right, so far, any question? Everybody's understanding what we're doing?
Just a brief about what Kubernetes is and all.
We will get to it, Romana. We are just setting the stage, so we've not even started it yet.
Okay.
Yeah. Any other question about the tooling so far? What you just need to know is you should be able to install it. That's it. I'm not expecting to know what is kubectl. I'm not expecting to know what is minikube. So far, whatever installation we've done, are you following it, everyone?
Yes, Samir.
Okay.
Yes, sir.
So let's go to minikube now. We have to set up kubectl now, right? So let's just copy this command. Choco install. So now we have git bash over here. Yes.
What is Choco for, Samir? Does it work in context of Kubernetes only, or?
No. Choco is for everything. I think you've installed several binaries. I think even AWS CLI, if you've installed it locally, you probably have installed using Choco. Choco is an installation manager, a package manager. Yeah, what happened? Is it doing something or no?
Run as an admin?
Yeah, I think so. That's where I'm going to go. Yeah, you have to run it as an admin. Okay, so that's installed. If I do kubectl, I keep doing this. They should have a standard, support all of it. So it is basically showing me the client version. If you look at it very closely, the server version would be errored out because there's no server at the moment that you can connect to. Okay, so that's the client version. And we are at 1.24. Okay, so let me get out from here. So what do we have right now? We have a VirtualBox downloaded and installed. We have minikube downloaded and installed. We have Choco downloaded and installed. Now we have to start minikube. So to start minikube, the command is here. Not here. Here. Let's see. This was for downloading, right? Start your cluster. So minikube start. But if you had not run this command, config set driver, you'll have to do minikube start with -- driver virtualbox. Remember this very well. If you just go by this documentation, you're going to error out because it doesn't know which driver to use. The default driver might not be virtualbox. Okay, but since we've already set the config as virtualbox driver, we can just go ahead and hopefully start this. Okay, so we'll go ahead and start this and see if there's any errors. So it is basically creating a minikube one node cluster on your laptop.
If this was hosted in AWS, the configuration would have been different. Driver would have been different.
We would not need to use any drivers. In AWS, you have two ways to install it. One is you will install it as a vanilla Kubernetes. Vanilla Kubernetes is you install everything. You install all the, well, I would say just park this question because I've not talked about Kubernetes at all. So you'll not follow. I'll have to talk about all the control plane components, and then we can talk as Kubernetes as vanilla or Kubernetes as a service.
Sure.
Just park it for a moment. Come on. Yeah, all the things that we've done right now is just setting the stage, creating an environment for us to play with. We haven't talked about Kubernetes. We've not talked about anything at all. There's a lot of catch up that we have to do. So it should potentially be creating this minikube virtual box over here. But while it is doing it, let's go ahead and read the documentation a bit. So what it's saying is interact with the cluster. So we can do kubectl get pod all minikube kubectl. We don't want to do it because we already have kubectl downloaded. We don't want to do this command, but let it come up or error the new. So it is pulling the external image. So it's going to take some time. So let's give it some time. We will move forward and start talking about Kubernetes in general. So this is where the whole setup will stop. There's a lot more that we can do from here on, but let's start talking. You have seen, so here's where you'll probably get ideas to why did I do catch up on so many technologies. I didn't go deep dive into any one of those, especially Docker. We've covered quite a lot. I mean, I wouldn't say we haven't deep dived, but for Docker, I had asked you to refer to an author in Udemy. Did anybody buy that course?
Yes, sir.
Okay. What about, apart from Rumana, anybody else?
Yes, Samir.
Okay. By Brett Fisher, right?
Yes.
I don't know whether I'm spelling his name right, but I felt he was pretty reasonable. There are other guys like Nana and Mumshad. I haven't gone through their courses. They're equally good. Okay. But I felt he was pretty reasonable for basics. So I would assume you still remember the Docker image concept. And then from the image, we create, what do we create?
Containers.
A container. You probably also remember we can exec inside the container. So there's a command we run, right? Docker
exec -it container ID.
Exactly. IT container ID /bin bash most of the time, right? So get inside the container. So you remember all of this. Great. That's a good thing. So let's get rid of this ones and then let's start from there. So I'm trying to connect those dots. Now assume for a moment, you are supposed to be managing Docker containers. You have 25 Docker images. And then when you deploy it, how many containers you'll have eventually? 25, right?
Yes.
You'll have 25 containers. Now, when those 25 containers come up, some of the containers you want to have 2 replicas. Okay, out of 20, you have 10 containers, you want 2 replicas. You want to sit and baby sitting, right? Do a health check of all containers. If any container goes down, you have to sit and bring it up. Okay. You have to assign containers to specific machine. What I mean by this, if you have 25 containers and if of all of the 25 containers, each one of them is asking for 1 GB of RAM, and you have a EC2 instance, which has 4 GB RAM. How many EC2 instances do you really need to come to 25 GB?
Roughly
7?
6, 7.
6 will be 24, right?
Yeah, 6, 7. Yeah,
So
7.
7. So 7 EC2 instances. So what I mean by this assign containers to specific machine, that means you'll have to distribute those 25 across 7 EC2 instances, correct?
Yes.
So you are responsible for it. And now all those 6 on each one of them, right? And 1 on one, last one maybe. So all those 6 containers that are running, you have to continue to do health check. So you have to have some mechanism to do health check. You should have some mechanism to make sure there are always 2 replicas, not more, not less, right? So all of that, you will have to do it. Imagine if you have to write a system that would be doing all of this that I'm seeing over here and maybe more, identifying where to put like you have already 7 over here, you want to schedule the 8th one, you know you cannot put over here, right? Because the capacity is already up. You will have to distribute to the other one, and then you can keep going it. So all that scheduling, you have to do it. So you have to build the system. Now, instead of you building the system, we have this tool, which is called Kubernetes. I think have I successfully delivered to you what is Kubernetes?
Yes, sir.
Yes, sir. I am clear.
Good.
Clear.
Yeah. So I wanted to go check a lot of YouTube videos, okay, after this session, and imagine that I haven't told you this, and try to figure out whether you're able to understand what people are saying. They will make it tough. Now, since you know this foundational idea, let's go and make it tough now.
Samir, under the hood, it'll use auto scaling for bringing in more resources on demand.
Rumana, looks like you've read something.
No, Samir, no.
Yeah.
I'm trying to connect the dots from previous session.
No, yeah, it will, but I would say park that question, because we will talk about the control. I mean, those are all good questions. Okay, Rumana, don't take me wrong, but I just want to make sure that we go a layer at a time. So we finish this layer, so we know what the big picture is, right? Let's look at the second layer now. This is where we will, and your question is going to be on the 3rd layer or 4th layer, Rumana. Okay. Good question, but let's park it for a moment. So we have looked at foundation, right? As to why do we need that tool? Because Docker container, to manage Docker container, you need to have some tooling. Docker, by definition, gives a tooling called Docker Swarm, which we have not even looked at, which I think you not even need unless there's a very small organization who wants to manage Docker containers using Swarm. It is a minified version of Kubernetes is what I look at it. Nobody, I mean, as far as what I've worked in all the organization, nobody uses Docker Swarm. But if you wanted to do something locally, Docker Swarm is probably the way to go, but don't even spend your energy and time in learning about it. Okay. Let's move to the next one. Now let me see if this, okay, this is perfect. kubectl is now configured to use minikube. So now if I say kubectl get pods, don't even worry about the command. It is showing me all the core pods. That means our Kubernetes is set up. The kubectl we've already installed. kubectl configuration has already been updated. And now we are able to see all the pods. So we are at the right place over here, but we are not going to jump in there at the moment because there's a lot of catch up that we have to do. We know why we need, come on, where did my pointer go? Now what we will do is, since we already know Kubernetes is the way to go, let's talk about what are the different components of a Kubernetes. So if I control plane, so if I draw a control plane like this, in the control plane, the heart of the control plane, the way I look at it, is a component Make some guesses. What do you think it will be?
API server.
Yes. It's Kube API server. Okay. There's a brain of the system too. What is the brain? Can somebody make a guess? It's a database is what I can tell you.
Yes.
Starts with E is what I can tell you.
TCP.
Yeah. etcd or etcd, whatever you call it. This is where all your data related thing is kept. There is muscle. Can anybody guess what the muscle power is?
Scheduler.
No.
Control.
Controllers. And then there is a worker or decision maker is what I'll tell you, more like a president. He makes decisions. Then we have these workers who are going to, or the muscle power who's going to really execute it, right? And that particular guy sitting up over here is called scheduler. I would not even call it a decision maker, frankly, because the only job that it does is scheduling. That's the only job. Okay. We'll talk a little more about it. Now, if we talk about nodes, so before I go here, there's a little bit I want to tell you is when you have an operating system right today, you have all the infrastructure down. What is infrastructure? CPU, hard drive, memory, input output device, so on and so forth, right? That's all the hardware. Is that hardware of any use to you without a OS? No, right? You have to install your OS, correct? Everybody knows what a OS is? Operating system. Okay.
Yes.
Now, on your operating system just alone doesn't really help you. It'll just give you a notepad and calculator and all of that. But on OS, you install your applications, correct? Your MS Office and all the other applications. So you have apps. Agree? Now, this same picture, I will draw it in a little different way. The only thing that I'll do is I'll rub this off. And I'm going to just partition this out like this. Each one of these is a node. Or in your world, you can think about it as EC2 instances. Okay. Don't quote me on it that Samir said all the nodes are supposed to be EC2 instances. What I'm saying is from a thought process, it's a machine, right? We call it node. You can think about EC2 machine. You can think about a VM. You can think about a fleet of laptops that you have. Those all could be nodes. Okay. So you have nodes over here, and each of the node has what I talked about earlier, right? CPU, hard drive, memory. That's it. You don't want to worry about input output. There's definitely going to be some bit of input output over here. But now the guy who's sitting on top of them is not OS, it is K8S. K8s is what they call it. And why do they call it K8s? Anybody knows?
Samir, between K and S, there are 8 letters.
Yeah. B-E-R-N-E-T-E. 1, 2, 3, 4, 5, 6, 7, 8. Glad I did not misspell it. So that's what it is. It's called even called K8s, or it's called Kubernetes. It's also could be called Kubernetes, so on and so forth. What is Kubernetes? I want to come here, okay? I want to come here, but I had to explain you about this. And now your Kubernetes runs over here, and all the applications can run on Kubernetes. What is Kubernetes, basically? In terms of language I'm talking about. Kubernetes is basically helmsman. And what is helmsman? If you have a ship you have a guy over here who's he's a captain, okay? It's not a bird. And then there is this guy this is the wheel. And there's this guy sitting over here next to the wheel and doing what the captain should do. This guy is called helmsman. He's the helmsman. Captain is not the helmsman. Captain gives him direction, but helmsman is the one who is responsible for steering the whole ship. So that's where Kubernetes comes into picture. It gives you the whole framework, but you're the one who's supposed to tell what do you want to do with it? What health checkups do you want to set up? What scheduling do you want to do? What pods have to be scheduled? All of that. And don't get confused. We've not talked about pods. So don't ask that question as yet. We will come to it. Now, knowing basics of a little bit of Kubernetes, at least from what it means, and we've looked at what this node are. So this one node from here is this one. So you can have as many nodes as you want, okay, under the hood. And on top, that's Kubernetes running. When there is a node like this, there are components over here. One is kubelet. Kubelet is responsible to be talking to the API server. So API server talks to kubelet. That's why it's the heart of the brain, whatever you call it. I usually like to call this guy's brain because it maintains all the state. And this guy is the one who's making all the decisions. So I keep it as kubelet. And for any scheduling kind of job, API server tells scheduler to do it and vice versa. Technically, they don't even need to talk because it all depends on the state of etcd. As soon as the state of etcd changes, the controller knows what actions to take. But just for simplicity, I'm drawing these arrows up and down there. So there's a kubelet which talks to the API server. There is a component called kubeproxy. And there's a component called container runtime. This component is what you are most familiar with, right? It could be Docker in your world. Or it could be any container. It could be CRIO. It could be anything. It doesn't have to be Docker. Okay. But in our world, since we've learned Docker, that's what Docker is. So what kubelet does is kubelet, as soon as it gets a command that a new pod has to be created or a new container has to be created, kubelet talks to the container runtime and say, go ahead and create this container. Imagine for a moment, keep Kubernetes completely out of the picture. If you are the one who's going to be creating a container, you're going to be running a Docker run command, right? And you want to stop a container, you're going to run a Docker stop command. So basically, kubelet is the one. Kubelet is behaving like you. Kubelet takes command from the API server, and kubelet tells the runtime, install it. Okay. There's definitely a networking component around here. And what is kubeproxy's responsibility? Kubeproxy's responsibility is basically to create a load balancer. If there's n number of pods and you want to create a service, that service has to load balance between all the 3 pods that you've created. That's what is the responsibility of kubeproxy, and probably maybe more. Will not delve into it at the moment.
Kubelet can be seen as Hellman.
What is that?
Direction. Kubelet can be seen as a Hellman.
No.
Taking direction and doing stuff.
No, Kubernetes is the helmsman. Kubernetes as the whole control plane is the helmsman. You can think about it as a helmsman from a clarity of perspective, but in general, the term Kubernetes is helmsman.
Okay.
So this is one node, right? These are multiple nodes we're talking about. You'll have like all the nodes around here.
Right. Yep.
So you'll have kubelet sitting over here. This guy is giving instruction. So who's giving instruction? The captain is giving instruction, right? Technically, if you look at it. So if you think these are helmsmen, which is from your thought process, it is right, because that's the one who's taking the instructions and executing it, asking somebody to execute it, right? So from that perspective, I can even call CR container runtime as the helmsman, because that is what is executing it, right? But let's not complicate it. From a term perspective, Kubernetes is the helmsman. You are the captain.
Okay.
You tell Kubernetes, and if you really look at it, Kubernetes is a black box. You're telling Kubernetes to do. You don't know what Kubernetes does, talks to who to get it executed. From your perspective, you're the captain, Kubernetes is the helmsman. Okay. Is it clear so far? Am I keeping it simplified enough for you to follow? Eugenia?
Yes, sir.
Good. All right.
So one more question I have, if I can.
Yeah, please.
So if not Docker, what is the replacement for Docker?
There are several. Google for it, Rumana.
Okay.
What are alternatives of Docker? Google for it. Kubernetes recently released. Kubernetes always used to be Docker. Kubernetes said, we are going to remove Docker. It's not Docker anymore. Any OCI image. And then please Google for OCI. Please Google for CRIO. And lastly, you can Google for CNCF. CNCF, I think so. Cloud native. Oh. Cloud Native Computing Foundation. If you have to come look at the toolings, what is being supported by Cloud Native. So what happened? I mean, let's talk a bit about Cloud Native over here. I wanted to keep it for later, but as soon as, okay, well, before we go there, I don't want to deviate it too much. Is everybody understanding this part here first? The different part of the control plane, we know etcd, we know controllers, and there are more than one controllers, okay? And that's why this S is over here. There's Kube API server, there's scheduler, there's kubelet, there's kubelet, kube proxy, container runtime. Everybody with me?
Yes.
Okay, so if somebody asks you what are the different parts of a control plane, these are the parts of the control plane. What are the parts? I mean, even after saying this, if they are not satisfied, you can start mentioning kubelet, but the question would not be right. According to me, this is what the control plane is, and this is what the node components are. But after you say this, if somebody doesn't feel satisfied, just go ahead and say kubelet, kube proxy, and container runtime. They might just not know Kubernetes enough. Okay, but these are control plane components. These are node components in our world where we are deploying minikube. All this is one. So if somebody has worked only on minikube, he might think the whole thing is a control plane, he or she. Okay. Let's make it a little more complicated now. Ready for it? Okay. We said there's a control plane component which has etcd, API server, scheduler, controllers. Correct? That's what we said. It doesn't necessarily have to be this way. What you could do is you could have a deployment where each of the components you can keep out, but most of the time what people do is they try to keep etcd out. So you're left with API server, you're left with controllers, and you're left with scheduler. And why do they keep it separately? etcd is, as I told you, is the brain, right? So you definitely don't want to have just one instance of etcd. You want to have multiple instances of etcd. Assignment for you today. Can somebody make a note of it and then update the assignment document, please?
Okay, sir.
I want you to watch videos about Raft algorithm. Raft has nothing to do with Kubernetes, but Raft is a leader election algorithm. Okay. So what does mean is if I have multiple nodes in a cluster, if I want one of them to be the leader, Because if all of them are leader, they're not going to know what to do with it, right? This, when we talk about clustering, which we've not even talked about, it's an advanced topic. We probably can cover up, if we continue for the next 3 months, we can cover up some of the advanced topics, okay? But what I want you to do is, I want you to understand when there are calls that are coming in, you always want to have one leader. This one leader is going to talk to the other members who are there. If this leader dies for whatever reason, there has to be a way for somebody else to be elected a leader. Okay, I'm not going to delve deep into it. HCD uses Raft algorithm for leader election.
For leader election?
Leader election.
Okay, choosing a leader. Okay.
Yeah. Okay, so that was about HCD.
What's the assignment, Samir?
Assignment is Raft algorithm.
Know about it?
Read about it, watch about it, and prepare a nice document with your understanding. Like, I want you to be thinking the way I'm trying to get to, right? To make a topic simplified. That's why I told you, read about, go watch about Kubernetes, about people talking about it. To make it simplified, I have to really understand the technology. So same way, when you're talking about Raft and writing about Raft, I don't want you to come and just tell me what you just found. Put it up in your own words. Simplify it. Relate it to a relationship, relate it to a real world, and then talk about it. Relate it maybe to a minister if you have to, or relate it to kids. I'm just throwing examples, okay? But what I'm saying is, get me a simplified version. Raft algorithm is not a simple algorithm to understand, okay? I'll just caution you about it. So Raft algorithm is the assignment. Who's going to make a note of it though? Okay, you'll update in the assignment. Okay, yeah. Good. The next one, let's finish up here, and we'll if needed, we'll come back again. For Kubernetes, you can go to Nana if the courses are not very expensive. But if it is in Udemy, there is CKA course by Mumshat Menembat. Should be about $19, or sometimes it drops down to $11. Just buy that course, okay? Go through it. With the fundamentals that I've talked about now, you should be able to catch up very easily with what he's saying. The whole reason I want you to go to him is because it will take you at least 3 months to prepare for it and then go ahead and answer the certification, which is Certified Kubernetes Administrator certification. I've already told you, take one certification on AWS. The second certification, what I'll tell you is take CKA. Okay, and if you're able to even do CKAD, because once you do CKA, it's only 20% more maybe you have to do for CKAD. You can do this certification too. Once that is done, then you're ready to do Terraform. So that's the order: AWS, CKA, CKAD, or both, and TCF. If you're able to do this before start of 2023, you're ready to be launched. You know what I mean, right? You're going to be better than anybody else who's even with 10-year experience with this under your banner. Make sense?
Yes, sir. What is CKA and what is CKAD?
CKA, I already said, is Certified Kubernetes Administrator. CKAD is Certified Kubernetes Application Developer.
Yeah, okay.
Yeah. It's a very, very, very looked out for certification. You know, there are a lot of guys who are already doing it now, but Kubernetes is pretty much in demand. Okay. So very important for you to do that. Now, with this little knowledge, let's go. I'm surprised in 1 hour or less than 1 hour, we're able to cover up so much. Interesting. Now let's look at over here. what are the different components that you see? etcd, are you able to recognize it?
Database.
API server, the brain, not the brain, the heart, controller manager, the controllers that I talked about, right?
Yes.
Kube proxy, which is part of the node. Scheduler, which is part of the control plane. So the 4 components, etcd, API server, controller, and scheduler. You see it here, right? The DNS service we didn't talk about. DNS service is mostly for within the cluster. You want to resolve IPs to DNS, right? So that's where the core DNS service is going to be. And then you want to provision your hard your storage. That's where the storage provisioner is for. Okay, so all the persistent related tasks that we're going to be talking about eventually is all going to be around here. So this is the control plane component. And then if you see over here, it tells you what is the namespace. Okay, all of them in a Kubernetes, in a minikube are running as pods. So what are pods? That's a term that I've used at least a couple of times. What are pods?
Samir, over there in that picture, the list of pods, did we see kubelet?
There's no kubelet that is showing up explicitly over here. No. It might be part of kube proxy too, but I don't see kubelet as a component. No. So what is pod? Pod could be related directly to containers. Okay, but the difference between pod and a container is a pod can have more than one container. In your current world, Jyoti, nobody ever deploys more than one container. It is one pod, one container. Okay, but what you need to understand, what you need to understand is you can put as many containers as you want in a single pod. Okay, make sense? So these are the running pods. Now what we will do is kubectl get namespaces. I want to get all the namespaces. So there's a default namespace. Let's go and see if there's anything in there. kubectl get pods -n is for namespace. Default, there should not be anything there. No resources found. So similarly, if you want to do kube public, you can do that. We've already done -a and we saw only this, so there should not be anything in there. The same way, if you do kube system, you'll see all of these pods. There's a lot of commands that you can really run. What you can do is kubectl -help. Okay. This is the second assignment for you. Romana, can you make a note of it? I want you to go through kubectl help, go through each of the commands. For example, there's a kubectl create command, right? I want you to find out what that create does. So what you can do is, first of all, top level, get me all this, start going through each one of them, okay? What we will see is eventually how many are we able to cover. So this exercise is going to be very important for you. You might not understand each and everything, but you're basically getting yourself familiarized with kubectl. So kubectl create -help. If I if I do this, it'll tell me what are the different options that are available for create. Okay, so I just want you to navigate through. Okay, I don't want you to write anything. I don't want you to come and say I have done it. No. Now it's all up to you. How much justice do you want to give to yourself? The more time you spend with this, trying to figure out what are the different parameters, what all I can do around, even though we've not seen all the commands, right? It'll help you a lot, is what I can tell you. Because in the end, when you do CKA, it is all about running commands successfully and how fast you can run command, because you don't even need to know what you just need to know the concept that yes, there's a concept like this. You should be able to navigate and find out using help. And yeah, this kubectl help is so powerful. I was really impressed when I started using it. Okay, there is this command called kubectl logs over here. So let's just play around a little bit. All containers -c, you can define containers. So what I will do is I'll do kubectl get pods -a, and I'll do a kubectl logs. I'll pick up one name over here. Let's see. -n. -n is required because you have to tell which namespace. So you see, it gives me the logs. When you do Docker logs and you see Docker logs, it gives you over here. But then when you start reading through this, it has a -c. What does that mean? Why is -c required? This should give you an indication that a pod may be having more than one. A pod may be having more than one container, right? And if it does have more than one container, how would you know if it has more than one container? Okay, so let's look at that first. So kubectl get pods -a. Let's pick up this guy from here, and then do a kubectl get pod this -n kube system. Okay, if I just run it, I'm not going to get a lot of information. I'll just see that, okay, it is there, it is in running, ready 1 of 1. That means one container, and that one container is ready. Did you brush? Good. If there were 2 containers, it would have shown 2 containers and 2 are ready. If one of the containers is on, it will show 1 of 2, so on and so forth, right? So now I want to get a little more detail as to what is basically constructing this pod. I can do -o YAML. I want to output not in this form. I want it to be shown as YAML or JSON. And now this is where I'm trying to connect the dots. So now what I want you to do as part of this assignment is, first of all, you'll go through the help, you'll navigate through everywhere, but you will take this and you can run the command and get it, okay? You don't have to look at what I'm sending. You can just look at this command. I want you to go through this structure. So instead of doing it here, let's go to Notepad and do it. Go through this structure, okay? And start clearing out this. Just keep the top level is what I'm trying to tell you. Status, I don't care because that's dynamically created. Just clear this. If you look very, very closely, any manifest that you pick up, this is the pod manifest, okay? But any manifest that we'll look around as we move forward, you would see it has only 4 top level. It has an API version, it has a kind, it has metadata, it has spec, okay? Then you can start putting in all the details that you have over here. And then look at it one by one. API version is pretty straight. You don't have to worry about every kind might have a different API version. That is one thing. There are different types of manifest. Pod is one of the manifest. Metadata, okay. Labels are pretty important. Name is pretty important because that is the name. If you really look at this guy here, and then look at this. Look at this, K6S8D. This is what it is, K6S8D. Okay, namespace. If you're already in a namespace, so for example, kubectl get ns. There are 2 tools that will allow us to. We are not going to look at it today. how to switch to a namespace. Okay, instead of wanting to give -n every single time, you should be able to switch to a specific namespace. I'm going to look at those tools tomorrow for you guys. Okay, but what I want you to know here is API version, kind, metadata. Metadata, you just need to know labels, name, namespace. That's it. You don't have to worry about anything at all for now. Name will uniquely identify that resource. Namespace will tell me which namespace do I want this pod to be running. Okay. Label will tell me, label we haven't talked about yet. I don't want to talk about it because it's a little complex topic. We'll probably cover it up tomorrow. Okay. Then when you come to spec, this is where the important piece is. You might be thinking, how do we tell which container? This is where it is. You're telling it, I want to use this image and the tag is this. I'm telling it, what is the image pull policy going to be? How often will the image be pulled? If the image is not already pulled, if not present, pull it. You have options like always, never, so on and so forth. Okay. We talked about the health check. Remember, this is what the health check is. We are saying failure threshold is 5. If it fails for 5 times, then it is failure. What is the health check URL? It is HTTP GET. We have other options also. We will look at it. But what I want you to do is, the whole intent is I want you to read this and just map it in your head that this is what it is supposed to do. There are multiple, don't get deviated by reading documentation. Like, okay, oh, there are how many different types of liveness probes? There are 2 types of probes. One is readiness probe, one is liveness probe. Don't get into all those details right now. Just pick up similarly, right? With this command, we picked up just one of the pod. Pick up all the 4 or 5 pods which are there in the control plane. Start reading through this. Nothing is going to give you more knowledge than reading through details of people who've already done it. Because once you read through this, and once you start understanding that, oh, there are only four types: API version, kind, metadata, and spec. And every single time metadata will have a name, it'll have a namespace, it'll have labels. Your brain is kind of ready to understand what I'm going to talk about next. So this assignment is very important for you. Does everybody get what I'm trying to get to here? Yeah, Mansa, Jyoti? Okay. Now, moving down, what is the name of the container? That's the name of the container is core DNS. So if I go here, and when I did this -o YAML, right? And you remember I said you can even specify -c. There's only one container, I mean, not here, basically in the logs. Here, I could always say -c and core DNS. If there were 2 containers, this is the way I would be able to tell which container I'm talking about. Okay. For example, if I say this, it will not find it. Okay. So you have to trust me that core DNS is the right name. So how did I get this? I got it from here. Then it is talking about what ports. You remember from Docker, we talked about ports and we were talking about port mapping. Yeah. So that's what is being done over here. It is saying container port 53, the name will be DNS, protocol is UDP. Container port 53, DNS TCP, container port 9153. They're having 2 different protocols, basically, UDP and TCP for 53 port. Container port 9153 also is being exposed. And now I was talking about there's a readiness probe and liveness probe, right? So let me take this guy a little up over here. We'll talk, just remind me tomorrow the question, what is readiness probe and what is liveness probe? We'll talk about this, okay? But both of them are health checks, okay? Let me probably just answer this. What is ready and what is live? Readiness is when you bring up the pod for the first time, right? Before the pod can start taking traffic, the kubelet is going to call this particular URL and check whether the pod is ready to take traffic or not. Only after this ready returns back successfully, that is response 200, HTTP response 200. It will say, okay, it is ready, and now it will start sending traffic. But now after it starts sending traffic, it wants to continuously check that the pod is really, or the container inside the pod is really live. that is when it is going to use this liveness probe every 10 seconds. Initial delay of 60 seconds. That means initially it will wait for 60 seconds. After that, every 10 seconds, it will start making this call to check whether the system is up. And the URL that it's going to call is health URL. Okay, that's the difference. And it does not mean that it will not call readiness probes at all. For whatever reason, if the container goes dead or it doesn't respond, and then the next time when it is coming up, it puts it out of scheduling, let's say, or out of service, the kubelet. And next time it wants to check that it is back ready to take traffic, the readiness probe is going to get activated. Okay, so every 10 seconds, it is having this readiness probe. So don't think that it'll just do readiness probe once and it is done. This is one place where people really make a lot of mistakes. Sometimes they overwhelm the kubelet. So now all these calls kubelet has to do, right? And if you're having, like, let's say, smaller pods that are running 200 pods in a node, and you're trying to call every 1 second, the kubelet is getting overwhelmed. Kubelet also has to talk to API server. Now kubelet also has to do a lot of health checks. So that's the reason why you should always try to keep your health check at a very optimal rate. Don't keep it like a second or whatever. Otherwise, your kubelet is going to keep dying. Kubelet will not know. As a effect of that, the scheduler will have problems. The API server will have problem. Everything, the hell breaks basically. So be careful about that. Moving down here, resources. You remember I talked about defining the CPU memory for the pod. This is the resource for the container. So if you see, we are under containers, right? So for the container, what resources do you want? I hope we are under the container. Yeah, we are under the container. So how much memory do you want and how much CPU do you want? CPU, 1000 M, 1000 millicore is 1 core. So out of 1000, it is giving 1/10 over here. Memory, the request memory, original memory is how much? Is 70 MI. Maximum it can go up to 170 MI. There's one thing that I would want to mention over here is CPU and memory. When you consider, right, there's this concept called compressible and non-compressible. What is compressible and non-compressible? Anybody knows? So memory is a non-compressible component. That means once you claim 170 MI, even if you want to fall down to 10 MI or 70 MI, you cannot. It cannot be compressed down. But CPU is a compressible component. So that's the reason why most of the time my recommendation always is, or even though these guys are doing for core DNS, by my recommendation always is, keep your memory at the exact same level, the request and the limit. So there is no context switching and decision making that it has to do, because as soon as it takes 170 MI, right, there's no way for you to go down. Okay, so I always prefer this as a best practice. And also if it's a Java based application, you have an option to define the XMX and XMS values. I always recommend that those values have to be equal, because if your system is a transactional system, and if it has to make a decision that, okay, give little memory, let the system run, your system is going to start crawling at one particular point when the load is very high. So instead of doing that, it's always a good practice to give it as much memory as you need, because memory is not a compressible component. But when it comes to CPU, you can always define a higher limit over here. You start with 100 M, you can go up to 1 millicore, 1 core, that is 1000 millicore. But if it doesn't require that much, if the load comes down, it will start falling down to 100 M. That's the whole idea. Are you guys understanding what I'm saying, or am I making it too complicated?
We are understanding.
Okay, yeah. This is the area of performance management, basically. There's a lot I can teach you in this area, but that's not the whole intent right now. Coming to security context, I would not really worry too much about it. I would not ask you to worry too much. Volume mount and volumes is what we'll have to look at. There's volumes And for those volumes, there will be defined volume mounts. Okay, so we have not gone through the whole concept of volumes over here, but from your understanding of volumes, right, in a Linux world, try to see if you're able to follow volumes and volume maps. We will eventually talk about config map. We will talk about secrets. We'll talk about persistent volume claims, so on and so forth. So there's a lot of catch up that we need to do, but for me to be able to move to the next level, I would want you to go through this and really understand, what it does. Let me Google, let me find out what are the different kinds of resources that are available in Kubernetes by default. Just research, have that mind for research. So this is where I would want you to really spend good amount of time understanding the system. Okay, there's one resource that I want you to definitely refer is this one's. Okay, I will make a note of it over here. When you go for a CK, CKAD, it's an open book exam. All this is available for you. So what I would suggest to you is, if you really are interested in Kubernetes over and above what I'll be teaching you, start going through this. Okay, so they have installation steps. Then if you see monitoring, logging, debugging, if you go here, you'll find a lot of information. Then if you go down, let's say networking, or you want to start with a tutorial, you can do this Kubernetes basic as in-depth introduction to Kubernetes, hello minikube. This is a good one, basically. Go through this. Okay, so you can start going through this. What is the stateless application, stateful application? What are services? Security. So if I go here, this is all about Kubernetes basic. It talks about, create a Kubernetes cluster, deploy an app. So you can try this one. So it will tell you how to deploy app. This will give you a lot of, and then they have interactive tutorial basically. So you can go through interactive tutorial over here, deploying an app. Launch interactive. And then you can start your scenario and start doing your work over here. Once you've done over here, you can come back to your installation and try to replicate the same thing locally. Does that make sense? Yeah, but understand one thing, right? It's all about how much you really want to learn. If I teach you something, someday, that's the reason why I'm focusing a lot on foundational concepts. But if you want to learn anything over and above it, you should know to go to the right documentation. Okay, because those documentations are always going to stay with you. So for example, this one, let's maximize this. So it's saying commands over here, right? It's in kubectl version. So let's run it, kubectl version. So it tells you what is this client, what is the server. Then it says kubectl get nodes. So I've talked about nodes under the kubectl as the operating system, right? That's what this is about. So kubectl get nodes. You see there's only one node. Now then you can continue over here and try to create a new deployment. So it is saying, so this is very simple basically. I would suggest you just go through this before tomorrow's session so that we can have more effective conversation. Can you do this, all of you?
Sure, yes, I will attend.
Yeah. So let's maybe I will stop recording over here and then we can probably start again.